I'm Antje Danielson. I'm the Director of Education at the MIT Energy Initiative, and I have the great honor to moderate the panel on supply chains, resilient supply chains. How do we create minerals, materials, and manufacturing capacity to deliver on the net zero carbon system? I have a wonderful panel here for you today. Super knowledgeable, and I'm hoping that this discussion just before our reception is going to keep you awake, and I'm hoping for lots and lots of questions. So we have 4 panelists, and I will just very briefly introduce them because they have all a lot of chops. And you can read about their honors and their achievements by going through the QR code on your tables. But I want to give you a very brief introduction to them. Our first panelist is Michot Foss. And Michelle comes to us from Rice University, where she is a fellow in energy, mineral, and materials at the Center for Energy Studies at the Baker Institute for Public Policy. And Michelle is very experienced. She has 40 years of experience in senior positions in energy and environmental research, consulting, and investment banking. And she also has a degree from the Colorado School of Mines, so she has some relationships to mineral mining and reclamation. She got her degrees she got a BS from the University of Louisiana in Lafayette, and a Master's of Science from the Colorado School of Mines, and a PhD from University of Houston. Our second speaker is Elsa Olivetti. Elsa is a professor here at MIT in the Department of Material Science and Engineering. She is also the co-founder of our MIT Climate and Sustainability Consortium, and Elsa was just recently made our Associate Dean of the School of Engineering, which is not actually in her bio that you can see, but this is like hot off the press. Her research focuses on reducing the significant burden of material production and consumption through increased use of recycled and waste materials, informing early stage design of new materials for effective scale-ups, and manufacturing processes on material supply chains. Elsa got a BS from the University of Virginia and a PhD in material sciences here from MIT. Our third speaker is Barchi Gillai, and I hope I'm saying your last name correctly. Barchi is the Associate Director of Value Chain Innovation Initiative at Stanford Graduate School of Business, and where she does research in the areas of sustainability and responsible supply chains, global supply chain design in complex trade environments, technological innovation, and the impact on value chain operations. She got her BS in engineering and management from the Technion University in Israel and Israel Institute of Technology, and she got an MS and a PhD from Stanford University. And our fourth panelist is Professor Amy Glasmeier, also here from MIT. She is a professor of economic and geography and regional planning in our Department of Urban Studies and Planning. And she has worked for a very long time on workforce issues. I just want to summarize it that way. The things to remember with Amy is that she invented the living wage calculator in 2020, and she is also running that. And her current research includes studying the role of economic conditions and their impact on public health, analyzing the costs of living in urban and rural areas and regions of despair. And Amy got her PhD and professional master's degree from the University of California in Berkeley. And if I could just ask the panelists to come up here. And each of them will give us a brief introduction to the supply chain issue and from their own perspective, starting with Michelle. And just come up and have a seat in your chairs, in those comfy chairs. If you would like to, you can speak at the podium, or you can...
Oh, I'm good. Well, all right, so us versus the reception. Let's see if we can get this done. And as I told everyone when I was asked to do this, the most important foundational topic is at the end of the day, the last panel at the end of the conference. How appropriate. You have no idea how much I get this. Everybody wants to do everything, and then, oh my God, materials. It's got to show up. I have a slide that I often use that I attribute to the semiconductors industry. It's great. A foundational way of thinking for everything that you have to do for modern semiconductors today. And materials are at the bottom. You take that out, it's a house of cards. This is the reality that, unfortunately, we're facing, but kind of in a backwards way, because what we're doing is stimulating demand, stimulating growth, trying to push everybody out there, get things done, and then worrying about, well, where it's all going to come from, what the supply chains look like, all the resilience problems that we're going to talk about today. I just want to put a few perspectives on the table that I haven't heard in the discussion so far. I really believe that everyone is trying to do the right thing, but there are really complicated political agendas on all sides, and there are a lot of nasty things in the world that we have to think about and deal with, and those are just the facts. I mean, I'm very much a realpolitik person, and I worry about this stuff a lot. Not everyone has full information, and because we don't have full information, cones of uncertainty, if y'all are familiar with that phrase, are huge. I will tell you right now, and all due respect to everyone, show my colors, you're not going to know what climate is like in 2100 until people get there. This is the problem that we've got. We don't know what's going to work until it gets into the market. We have what we call the energy transition valley of death. Those of you who work in venture cap and innovation and startups, you know that the valley of death terminology is well-trod ground. We're in that right now. A lot of stuff is not going to make it past go. We're going to be doing GAO reports in about 5 years, I predict, and we're going to look at what went wrong and why we didn't get all the benefits out of the stuff we're doing today. And it's because we don't think about the foundations. We kick the can down the road. It's messy. Nobody wants to deal with it. It's a problem. And worse, we don't actually have a comparative advantage right now. If you look back at our mining and minerals businesses, even our oil and gas businesses, everything that we've used to build the United States economy, in World War II, we supplied material to the world. We supplied energy for the Allied effort. We supplied it out of our mines for the industries to build the material for defense and to win the conflict. And we've been the main supplier ever since. And then in the mid-1980s, we started shedding that capacity abroad. Why? Well, we had done a good job of using up our domestic resources. We still have some, but a lot of what we have is on the old side. We're not cheap. We are expensive. We have a lot of hurdles to getting projects off the ground. We have a lot of challenges all over the place in the material supply chains related to sourcing, quality, the mining industry itself having to deal with all the sustainability metrics that everybody wants to see the industry do, and it's not cheap. We're constantly debating what profit is. Why is profit so important? You can't do sustainability and you can't report on it and talk about it and measure it and transfer it and everything else unless you're profitable. So the venture has to have a positive NPV in your analysis going into it. If it doesn't, then everything else is going to be a struggle. We have workforce challenges that we're going to come to. We have maturity. So a lot of you have probably seen some of the stuff that's rolling around about how many tons of this we need and tons of that and so on. And what everybody does is just take, some number of electric vehicles that are going to be on the road or whatever else, and then times X, for the particular metal. All of that is wrong because, first of all of our supply right now is coming from facilities that predate the 1990s. That was the last big boom in minerals investment. And because we have huge cycle times getting new projects off the ground and new logistics developed and people to staff them and everyone to do the extreme technical work to design and plan all of these facilities and make sure that the right decisions are getting made on processing and smelting and refining, which we don't do in our country anymore, either for a whole bunch of reasons. And so we have enormous challenges. We're going to talk about geopolitics in a bit. I'll be very blunt. We're in a world in which there is a very, very large dominant player in material supply chains, and that is China. 45% of what we take in tonnage for metals, construction materials, the whole shebang comes from that one country. They're doing what we did in the 1930s and 40s out of their own domestic resources. They have had to go outside of China to make investment in a lot of strategic locations because that's the only way they can feed their industrial supply chains. And their supply chains are extremely powerful because they are the factory to the world. They're the ones who are supplying our components. When we buy germanium, gallium, if you were listening to the news this summer, Chinese export controls on those, it's not coming to us as raw material, it's coming in these things and the components in them. And so our supply chain fragility is much more pronounced than people realize because of this problem. We're all trying to figure out what to do about this, and it's leading to a whole bunch of arrangements that are in the least troubling, especially to people like me who have spent so much time working abroad in developing countries. I was a USAID implementer for many, many, many years. I've seen what happens when you go into resource-rich but fragile states and try to work with those governments to get them to do the right thing in terms of developing their resources for economic development, and how disruptive it is when we, the big consuming countries, come in with our own interests first. And this is a really hard thing to manage. So we have a lot of challenges, a lot of issues, and there's no way else to think about it except to be just blunt and practical. Fundamentals, just to give you an idea, the largest, single most important commodity group that we use are plastics and resins, which means we have to protect our hydrocarbon value chains. We've always done this by leveraging petroleum fuels. So you got a lot of stuff when you pull out a barrel equivalent of oil. And people don't realize that and how important it is and how crucial it is and how difficult it's going to be to unhook that. Just go talk to Lego. We have a new Lego case study that is worth looking at seriously for that company's experience in trying to come up with different feedstock for something that I doubt any mother, I'm not a mom, but I grew up with this stuff, any mother will want to oppose. Mothers against Legos? I don't think so. I think that's one that we can safely bet is not going to happen. So just to kind of sum up, I guess, what I'm going to do is invite you to show and tell during the reception. So I brought some things that I just am going to talk about when we're over drinks. One is, this is what mined ore looks like. This is a sample from our lead zinc facilities in Missouri, 1,000 feet underground, 3% lead, about 1% zinc, about 0.25% copper. We don't refine this, we don't smelt this in the United States. We take the concentrates and they go to that wonderful big country across the Pacific, China, and then we buy that back for the rest of the manufacturing that we do. The other sample I have is the future of copper. This is nano copper in a very complex additive manufacturing sheet that Elsa probably knows a ton about, that goes into semiconductor manufacturing, very elegant stuff. But the thing that I'm most excited about and most proud of is this. This is carbon nanotubes. What's the future of materials? Carbon. And I know everybody wants to not think about carbon, but you have to. This is conductive as copper. It's a fraction of the weight of copper. If we can figure out how to use this stuff, then we have an alternative to our materials dilemmas, I think. So on to the next one, I think.
Yeah, so thank you for this very provocative and kind of depressing introduction.
Oh, look at this one. I love this one. So this is woven carbon nanotube. I was talking to a friend of mine. We've got our Baker Institute gala coming up, the 30th anniversary, and I'm like, just give me enough for a dress. I'll walk around, advertising what I think the future of materials is. So that's uplifting. This is uplifting. This is material science, exquisite material science at the atomistic level.
So Elsa, it's a hard act to follow.
This is what happens when you're in the most important session right before the reception, I guess.
Most important session before the reception.
You wanted to give us a case example, right?
Well, maybe I'll shift tactics given the opener. One thing I'll tell you all is that all of the undergraduates here at MIT had this, they're into swag, as we all know, undergrad communities are, and they got really into graphene socks. So carbon-based socks. So just to kind of laze off of the points that Michelle made, I agree on the carbon point in multiple ways. I mean, I don't want to get off onto that tangent, but the idea of creating a value-added product from coal is a really important opportunity for communities in Wyoming, for example. So I'll underscore that point. So I guess I'm contemplating what words to share with you all, maybe evolving a bit given the provocative way Michelle began. And maybe I'll kind of underscore one of the points, sort of underscore the punchline of what we find when we're thinking about material supply chain challenges. So Michelle made the point around geographic concentration, right? And that's in all stages of the value chain. It's not just in extraction, it's in refining, it's, so we have to not just always think about the mine. It's building capacity and capability and innovating. There's opportunity throughout the value chain. So that's one kind of underscoring of a point Michelle made. Not to continue the gloom and doom here, but the challenges are only going to become more significant, right? Because ore grades are declining. And the kinds of refining processes that we need, I did have some slides, but I think we won't go there given the time. But the refining processes we need at the grades we need them are those that we can get most quickly have the biggest environmental footprint, right? So the kind of directions are troublesome in multiple ways. And so we need innovation, and we need it along the value chain. So, punchlines being geographically concentrated throughout the value chain, environmental challenges are pressing currently and will become more so if we don't become quite clever and all become material scientists. I'll lean into that. And it's sort of, I don't think you can given what I just said, those that are most quickly available, we can't underemphasize this challenge about temporal disconnects, right? It takes a long time to build a project. It takes a long time to invest in capacity, but there's also this cone of uncertainty. So making decisions in this uncertain way and understanding how to invest, how to inform investment is challenging given that temporal disconnect. And so there's a role for analytics. There's a role to think about it analytically. There's a role to think about it from a extractive metallurgy perspective. But also the reason why I love this topic, is because it needs all the stakeholders, the backgrounds of every single flavor. Sort of people and the environment meet at the mine, right? And throughout the value chain.
Or not.
We'd like them to. How about that? Yes, so I'll make that point. And then maybe, it's important to be able to communicate the complexity and the nuance, right? It's not, we say we're not running out. We're not running out of anything, right? Well, it's at what price, and I mean price in the broadest definition of the word. We will get it, whatever it takes. And so can we do that? But as prices go up, that as there's more volatility, then there's less opportunity in terms of doing a transition in an equitable, resilient way. So I'll underscore that. And let's see. And the other thing, so in addition to this complexity, we can't treat all materials equally. And I think Michelle's show and tell ore body is an important part of that. It's not one material, right? Each thing we're digging out is multi-material, and so mining companies and refining companies are making decisions in this multi-vectored space, and so that's also particularly challenging. So I think partly these are exciting problems because they're hard problems and require us to kind of work together in particularly innovative ways. So I was going to tell a little bit about the kind of this is related to one other point I made. There's a lot of what I sort of cheekily call whack-a-mole in this space, like, oh, we're running out of lithium, quickly. Oh, there's a lot of challenges with cobalt, quickly, let's all run over here. Let's all run to nickel. And that's not good, because then we have, for obvious reasons, whack-a-mole is troubling, but we have these very profound, acute impacts on regions that then the geopolitical, focus goes somewhere else in our attention deficit situation, right? And so, and we see that in Africa, we see that now in the DRC, because everybody said, lots of challenges in Congo, and now there's a lot of economic development opportunity lost there. And so the story of nickel is starting to be that story, where there's tremendous economic development and opportunity in Indonesia at pretty expensive environmental cost to a pretty biodiverse, environmentally splendid region. And so how does that government make that trade-off in a thoughtful way when we're all saying, we need green nickel, we need it now? That's really hard. So I think that, trying to get away from the hype factor and thinking deeply in sustained ways about these supply chains. And so, I feel the edge of the attention span situation headed towards phosphorus. So I'm going to Morocco next week to try to talk to folks about how do we anticipate the chaos that is about to happen as we think about moving away from, first we moved away from cobalt, now we're going to move away from nickel. That sends us to lithium iron phosphate. So now we all need to think about phosphorus. So, and the folks on this panel know deeply about the multiple dimensions of these issues. So I think I'm just underscoring the points that Michelle made with maybe a little bit of specificity here and there, but I think we can't underestimate the deep ways in which we need to think about creating resilient supply chains, given this level of complexity and the fact that they really do require interdisciplinary solutions, and that engagement is hard and long. So it's a marathon, not a sprint. How about that?
Thank you.
That's uplifting, right?
That's we'll see. We have an hour to discuss that. Barchi, I think you wanted to illustrate a little bit what the monopoly situation is by giving us an example on solar panels, right?
Right, yeah. And I actually have a presentation that I would like to show you all. So I'll move to the podium and show you my presentation. And where is, okay. So yes, I'm going to share with you a little bit of information about the structure of the solar PV supply chain and how we can try and improve the resilience of this supply chain. First, just a little bit of background. There are actually two technologies that dominate the global solar PV markets these days. One uses crystalline silicon as the key raw material, and the other is cadmium telluride thin film technology. As you can see from the diagram on the right that shows the market share of each of these technologies, the crystalline silicon one is actually by far the most dominating one, both globally in general and also specifically in the US. And because of that, I'm going to dedicate the rest of this very short presentation only to the supply chain that uses the silicon as the key raw material. So how does the production process looks like? It starts with the purification of silicon to create polysilicon, which is then melted at very high temperatures to form ingots. Next, those ingots are sliced into thin silicon wafers, which are then processed into solar PV cells. And the last step is to arrange multiple cells together and connect them electronically in order to form the solar PV modules or panels. And typically each of those 5 steps take place in a separate manufacturing facility, which adds more complexity to the supply chain. In addition to silicon, there are also some other materials that are needed in the production process. I listed here a few of them, like the silver and glass and aluminum. There are several other materials that are needed. Those pie charts that you see show the manufacturing capacity for each of those segments by country. And more specifically, it shows the manufacturing capacity in China, which is shown in red, and the rest of the world in blue. And as is clear from these charts, China dominates all segments of the supply chain. They have probably like 80% or more market share. This has not always been the case. The supply chain used to be more diversified. There were more countries that were leaders in these areas. But the current structure and the dominance of China is a result of more than 20 years of strategic investments by the Chinese government, which identified solar as an important sector for the country's economic growth. In contrast, in the US, as of now, there is no active silicon ingot, wafer, or cell production, even though this is about to change in the coming years, because since the Inflation Reduction Act passed last year, there have been quite a few announcements of new facilities that are planned to be built in the US. Still, in the short term, China's dominance is expected to persist. So what are the pros and cons of the current situation? To be clear, there are definitely some benefits to all the capacity and the expertise that China built over the years. Because of the economies of scale that their manufacturing facilities enjoy, and because of their continued investment in innovation, then the production cost in each of those segments of the process reduced dramatically. And that led to over 80% reduction in the price of solar modules over the last decades or so. And that actually made solar one of the most affordable electricity generating technologies in the world. At the same time, any supply chain that is so concentrated exposes the market to different risks that can lead to unexpected shortages or price hikes. And I listed here a few of those risks. At the country level, if, for instance, there are changes in policies, say the Chinese government decides to reduce subsidies that they give to solar manufacturers, then it may force some of them out of business. Some parts of the supply chain are also concentrated in a relatively small geographic area, and then it can expose the supply chain to risks related to natural disasters, for example. And finally, some segments of the supply chain are also concentrated at the company and facility level, and in this case, there may be issues related to failure of the manufacturing equipment and other potential issues. Now, on top of that, we also need to consider the specific issues related to China. We are all aware of the growing tensions with the US. There are also concerns about human rights violations and so on. And therefore, because of all these issues, it definitely makes sense to try and diversify the supply chain, reduce reliance on China, so that we can make the supply chain more resilient. So I listed here a few strategies to achieve this. None of them is really easy to achieve, but still, this can be a goal. One is to establish or expand domestic manufacturing capabilities, so that obviously we need to rely less on imports. The second, in addition to building manufacturing capabilities in those 5 segments of the core manufacturing process of the solar modules, we also need to make sure that we have a large enough supporting supply network for all those additional materials and components that are needed in the process of building those solar modules. And finally, and this is especially important in the short term, but it's also important in general, is to strengthen trade ties with solar PV manufacturers in other countries beyond China. There aren't that many at the moment, but for instance, India seems to emerge as a potential additional location beyond China to export solar modules. So these are just some briefly explained strategies, and that's it for now, I think. Yes.
Thank you, Barchi. for bringing us back to level-headed discussions. Every supply chain, Amy, has people involved, and there are issues around people. So coming from looking at labor and issues with labor, what are your thoughts on supply chains and sustainability and resiliency and so forth?
Well, the first thing I'd like to say is it is always an extraordinary pleasure to be in a room full of women. They're just so cool. And I come from a department that's mostly social science, and but we still have, and we have about 50% women, about 45, 50% women. So I'm married to a miner. My husband's been a geologist his entire career. He has met legends like Chuck Fipke, who found the Canadian pipes, diamond pipes, and then lost most of his money, unfortunately. My husband worked most of the time outside of the United States, but I've been all over the U.S. in mines and in old tailing piles, and wandering around going, what did I marry this guy for? I mean, he comes home filthy dirty every day. It's just like, why can't you have a normal job? But it's been really fun, and it's been really interesting, and it's also allowed me to think about the world at a scale that I think is really appropriate at this moment. America has had moments of being quite self-satisfied and focused within, and I think we are begrudgingly, in some instances, actually looking outside and trying to think about what it is that we have to do in order to be probably more modest in who we are, because I think that some level of modesty is probably appropriate, given that some of the statistics that have been said indicate that we do not quite have what we had in the past, but we do have incredible ingenuity. So I want to tell you one story, then I'm going to tell you a series of stories. So right now, my husband's been working on a uranium mine, to bring a uranium mine to production in Niger. And about every 5 years, it comes up and it looks like it's going to go. And then, bam, something wipes it out. Well, this time, it's a little different, because the geopolitics are going to be such that France is probably going to walk away from Niger. The United States has a strategic base in Niger. They're thinking about the potential of what are they going to do and whether they're going to stay. But this just underscores how chaotic the minerals industry is. And I don't think it's ever been anything other than it. And so maybe that's a little bit of the story, which is you just have to live with the level of risk that faces you every day. The second thing that I want to talk about is, and it's sort of a story, is about 5 years ago I got a National Science Foundation grant to study catastrophic failure in the utility sector. Now, I didn't know one thing about it. They needed a social scientist who could actually work with behavior, so I got drafted. And it turned out to be a totally fun project, and also taught me a lot. And what it taught me was we're building a system and adding things with incompatible intellectual capabilities. And what I mean by that is we began to investigate where the biggest errors in the utility sector were manifesting and why they were manifesting. And it turns out that as we try to connect computers with other types of electronics and other types of materials and distant production, we're putting different business cultures together, and they are not compatible. For example, the software engineers think nothing of the guys that are in the plants. They do not think anything about them, and yet the guys run the plants. And the people who are at the smallest scale plants, nobody really cares about them, but they actually are important sources of energy at the smallest scale. And nobody, when things go wrong, they get treated last, which is really problematic for an integrated local economy. Let's say you had a lumber mill, and the lumber mill is run by a power plant, and the power plant goes kaput, and then that little town sits and waits for somebody at the end of the line to come and do their work. And we had something very similar to that, but only at a gigantic scale here in Boston about 5 years ago now, I can't believe that, where we had cast iron pipes out west in a couple of the western suburbs of Boston, and they had a non-registered, non-tech registered person who was asked to install a new piece of equipment, and then he had to regas the lines. Well, when he regassed the lines, he didn't know he was dealing with cast iron and the modern piece of equipment that he was essentially working on, and it blew 5 miles of pipe all over, broke it into thousands of pieces. People died, houses were exploded. They had to hire a luxury liner, a leisure liner that you take out in the Caribbean to give the workers a place to sleep in the Boston Harbor, because there was no place to put 5,000 people who were working on this problem. So we have these circumstances that are above and beyond the actual natural resources that we're talking about. We're talking about, do we have the capacity to actually monitor the systems that we're building? And can we get the software engineers to talk to the persons that are running the plants, or even 2 people operating 2 buildings on a campus like MIT who don't talk to each other, or they point fingers at each other when there's a problem. It's cold here. It's not my fault. And so it's a situation in which the catastrophic failure as a metaphor is actually really powerful for us, because we have built things in pieces, and some pieces are 50 years old, some pieces are 2 weeks old, and we don't have a mental model of how to manage this kind of tumult and disarticulation, which is what we live with today. I want to say, as a concluding conversation, because Angie wanted me to say this, and I'm happy to say it. So I've done a lot of work in workforce development. I've worked in Appalachia. I've worked in a number of places in the United States where workforce is a really important part of the supply chain. And one of the challenges that we have is that we don't have the training programs for the future. We don't have actually the number of male or female workers to work in some of the mining industries in the future. We don't ourselves really appreciate the fact that the industry is going to change, it's going to have to change, and if we don't have the training programs now, we are certainly not going to have them when we need the new ones that take place. And as we see all of these changes coming out of the White House, one of the big questions is, who's going to do what? And where are the programs that are needed so that we can actually move through the future with this increasingly catastrophic experience?
Wow.
Bad and ugly.
I think we could talk about this for hours. Go ahead, Elsa.
I can just make a comment. Thank you, Amy. We didn't applaud you, but I really enjoyed your story. I just will make 2 points related, underscoring the last point you just made about workforce development, or the needs of, that we don't have the right programs to train for these jobs. And we hear that time and time again from the folks we work with in the mining industry. And part of that has to do with the programs that don't exist, but also it has to do with the narrative around that profession, and and so there's a conversation at MIT right now about how do we start to build a positive narrative around that. We are dependent on these materials, they're necessary, the House of Cards model, and so how do we build interest and engagement, not only the programs, but folks to enroll in said programs, because so it's not necessarily, how would they make those jobs attractive? So just to underscore that point. And then maybe to underscore the first point you were making around the sort of different kinds of cultures that need to come together in the materials space. Partly I wanted to make this point because in the 4 things we just talked about, recycling didn't come up, and so I wanted to at least mention briefly the sort of challenge of kind of secondary material and recycling is that the rate of demand is going up in such a way that it's going to take a good bit for the secondary supply to tip that curve and fill that supply-demand gap. So we need to be and what that means right now is that most of the companies, most of the space in recycling is startups. So that's sort of what I mean about this cultural difference, is that having the startup community be able to talk to the Rio Tintos and Vales of the world at this sort of scale mismatch is another opportunity for culture bridging that I think is in terms of how do we develop the right technologies that are going to be most leveraged at scale. And so just kind of bringing those 2 points to the mining space a bit.
Great.
I love bringing social scientists together with scientists. Just
We're all wannabe scientists.
bubbles
That's how I
up
feel about
it. The last point really, or the last 2 points that you made and Amy and Elsa sort of leads me to, well, how do we build a new supply chain, right? And Barchi, did you think about that at all in your, how would you build a supply chain for solar energy here in the US, for example?
Right. So first of all, workforce development is definitely one point to keep in mind with the solar energy too, because all these new facilities that are being built or are in planning, each of them will need hundreds or thousands of workers to operate all the equipment and to ensure that those facilities can run in full capacity. And so it's really important to already put in place education and training programs to ensure that once those facilities are up and running, we have a large enough pool of skilled workers to operate them. Another thing that comes to mind specifically with relation to the solar industry is so I talked about those 5 segments of the supply chain that are needed in order to build solar modules. When I last looked at the list of plants that are in planning or under construction, a lot more of capacity was dedicated to the last step of the process, the module assembly, which makes sense as a first step because whenever you build a new facility, you want to make sure that you have customers to sell whatever you're building. So it makes sense to start with the last step. But it's important over time to make sure that we also build enough capacity upstream in the cell production and the wafer and ingot steps, because otherwise we will still rely on a lot of imports for the cells and the other components. So that's another thing to keep in mind. If you really want to have a resilient domestic supply chain, we have to invest in all parts of the supply chain.
I have a question to that, but I also see that Elsa is kind of sitting.
Oh, no,
okay,
carry on.
Can I ask
No, I'm good, yeah.
So I think the elephant in the room really, with what you just described as well, is this tension between global supply chains and building domestic supply chains. And there are so many issues related to that, global economics, local economics, geopolitics, international policies, domestic policies, and so forth. So do you have something that you want to say about this tension between geopolitics and domestic or international or global supply chains and domestic supply chains?
2 thoughts. One comes from somebody else, not me, a friend, who made the point the other day, which I think is basically where we are. If what we care about is speed, we're just going to do this so fast because this is what people believe has to be done, then we have no choice except to take advantage of the global supply chains that exist, the major supplier, China, and just move forward in that direction. A lot of us view that as untenable, which I'll come to in a second. The other fork in the road is we go slower and we think about what it really will take if we want to build our industry, build our capacity, build our workforce, figure out the materials problems, And we didn't even really unpack the specificity that Elsa mentioned, because there are so many things. Quality matters, the quality of the material. Nickel for battery grade is different than nickel that just goes into your hardware in your home for your cabinetry. I mean, there are so many issues that permeate the material supply chains like that we haven't thought through. So we kind of have these forks in the road. I lean to, let's slow things down and think about what we're really investing in and what the results are that we want long term. Now, the untenable part of the first fork, we didn't talk about defense. We didn't talk about competing uses. Every single mineral that we're interested in for energy has a competing demand. So whether it's pharmaceuticals, if you plow lithium into batteries, platinum into fuel cells, and everything else, you're making costs higher for really important healthcare, medical treatments, advanced treatments that affect people and affect lives, and so on down the road. I mean, every single thing is like this. And we never talk about that. We're obsessing on what we need in order to achieve whatever we want to call this clean energy build out, and we're not thinking about everything else that has to get done. And I think that's another reason for going slower, so that we can contemplate those. But by going fast, what you're doing is you're actually deepening the issue that everybody faces when you talk about one of those competing uses, which is defense. We're advising NATO, this has been going on for a couple of years now, on their own internal reviews for European defense, NATO defense as well, overall. The U.S. is in a much different position than the rest of the NATO countries on this, and this is one of the issues. What needs to be done to have supply chain resilience in light of Ukraine, in light of Russia, in light of China, and all of this. And this is where you really see the international tensions. What's our priority? What's critical? What's not critical? Frankly, I'll tell you, and I'm sorry, I have to say this, I cannot imagine a major Indo-Pacific conflict given the situation that we're in. How would we do this? We don't control anything. How would we ensure our supply chains in order to be able to execute the right way with minimum loss of life and minimum damage? I don't know how we would do that. And that's a really, really serious issue that everyone on the continent in Europe has been facing since Russia invaded Ukraine. And there are no easy answers on this. And inside NATO, in fact, it came up again this morning in one of the plenary meetings, are serious questions about whether defense should be the priority. All this clean energy stuff that's competing for material, that can wait. We need to make sure that those supply chains are well thought, well stabilized, well sourced, and resilient. And that's a really hard trade-off, really, really hard trade-off. And so I don't have an answer for this other than dialogue and to try to get all the information on the table, deal with those cones of uncertainty, and think about, things in the way that we really need to. I mean, we're running around building alliances with different countries to try to secure our supply chains. Everybody else is doing this. So the past few months, our Secretary of State, Secretary Blinken, went to Africa to deal with regimes that we haven't dealt with in like decades, seriously, and with the Saudis, because the Saudis are interested in making investments, and with the Japanese following, because the Japanese are having the same conversations. Now, think about the receiving end on the African continent of those visits and what those thoughts might be. So these are extremely complicated issues that require time and statesmanship. We're starting to talk about minerals diplomacy, materials diplomacy, and statecraft for materials diplomacy. And I think we need to figure out how to develop that. And so I want to slow down and make sure we do those things the right way, I guess.
So I think that was a very good point made. Either we go slow or we
go fast.
We go
there
fast,
are choices.
and those are the two choices. Do you have any thoughts, the three of you, any thoughts on this? Or
So one of the things that I wonder is whether or not the United States knows how to go slow.
In a 2-year cycle, no.
And the reason that I say that is we take shortcuts, and we make decisions that have consequences for our industrial capacity, that if we slowed things down and we actually said, would it be better for us, for a strategic industry, would it be better for us to actually subsidize that strategic industry, or, because it's in a tight squeeze, or let it go downhill and disappear, because that's what modern economics is about. And we have done that since we started building, guns with, just plain old black powder. And we'd have destroyed industries when we're done with warring, that then we look back afterwards in 20 years and say, gee, we shouldn't have let that micro machining industry disappear, because now we need it again. And that happened for sure in the case of the American watch industry, which we dominated at one point. And then when the Second World War was over, we turned the taps off, literally just sent them a letter and said, thank you very much for your effort to the United States security. And the factories were gone in a couple of years. So I think we don't have very good planning functions.
We used to, though. So everyone in Washington, all of my longtime friends there, and so I'm talking about people who have been around the block as many years as I have, like close to 50. Truman had a long-term plan for materials. Truman had ideas. I mean, you had to think longer term in those days. Think about what was going on. We were in the Cold War. Then we were worried about stuff. And so there was actually real long-term planning that took place. And to your very, very great point about letting industries go, one of the things that you all could do if you're really interested in this, get your hands on the December 1984 issue of Business Week. Let me tell you, it's not easy. You can get it on eBay. You can get a hard copy on eBay. And
Maybe
if
that
you're
should
really
be an
nice
award
to me,
next
I'll
year.
share my scanned copy. That I used to have this because in 1984 I was in Golden, Colorado, at Colorado School of Mines. The mining industry was collapsing. We had gone through this enormous commodity rush, you know this, where we're all of us out there who are working on this stuff are watching this, affecting this. This is when a lot of capacity came in. This is also when countries got very adventurous and nationalized their industry. So at copper nationalization in Chile, we had the Indonesians doing all sorts of things there and all over the Pacific and, all over Africa, all of this stuff happening at the same time. Back to my point about what we're actually relying on right now, that's where it came from, was that period of time when we built all that capacity. And then we let it die. 1984.
Or we subsidized the wrong things.
The death of mining, or we subsidized the wrong things. The death of mining is the cover story on Business Week.
Let's pivot to how we can build and not let things die.
Not let things die.
So I'm also a little bit curious about the environmental impact of going fast or going slow, or if going fast or going slow has an impact on how we deal with environment and sustainability. And Elsa, you had this example of nickel in Indonesia that they have this extraordinary opportunity, but it might be to the detriment of this beautiful environment that they have. Would we face something similar here in the U.S. or in other countries where we charge forward? What are your thoughts on that?
Sure. Partly what I was picking up from the conversation before is what do we mean by we, and whose choice is it to go slow or fast? And so it could be there's a role for universities here and students in terms of developing the insights to help us think about what it is to be deliberate about these decisions. And I see the students I work with in the audience who spent time in Indonesia to think about kind of how do we help increase the amount of transparency and communication to help there be more awareness of those sorts of trade-offs. So we can't control the federal government, but we can have this dialogue at in university spaces and these sorts of spaces to understand what the impacts of these things would be. And most of the data that we've looked at, as I said, is each additional ton of X is at a higher environmental cost if we do it as planned, right? As currently planned or as in current, best available technology. So I think the direct answer to your question is I think there are significant impacts sort of no matter where we do it now, if we aren't deliberate about the way we do that. And I think it is about having kind of local, contextual conversations. I often say that sort of answer to every environmental question, from a life cycle perspective is it depends, right? It depends on where you're doing the work and what the grid is and what what practices are being adopted there. So, I think there is something about, I guess the reality of what's happening on the ground and the role that we can play there. So.
I think, Elsa, you could add that in Indonesia is a great snapshot right now, so you're perfectly right to bring that up. Because what's happening is an amazing amount of Chinese investment flowing into the country chasing a low-quality source, laterite nickel, so basically digging up tropical dirt, with a bet that by adding complexity and processing, you can reach the class of nickel, the quality of nickel that battery makers want. And the Indonesian government is going along with this, risking the environmental damage because they want economic development. This is a comparable thing to what happened in the 1980s. The country's making the same kinds of decisions. How do I build around my resource? What do I want to get out of this? What's the economic development bet that's being made? The situation with China, as everybody knows, with Indonesia is complex, if nothing. So you've got to figure out that and whether that's really something you want to live with. I mean, it's a great place to look right now to try to figure out, how do we build in light of our tendencies as humans to behave the way we behave.
I was going to make one point on this going slow. I know we need to get questions from this crowd, but so part of what we can do immediately is that we are all consumers, and so this point about enough or change of behavior, that's immediate and constant. And there was lots of discussions about moms earlier, so that's a role. I think it is about us really genuinely having a conversation with ourselves about what is enough, and that is, I don't think we can say that enough. So that's a way to move fast.
Thank you, Elsa. I think that is actually a really important point to make, as was your other point that universities can contribute to going through some of this chaos, right? And helping us go through some of this chaos.
So interestingly, I'm thinking about my students. So I teach from poverty to supply chains and physical geography of various forms. And I realized, listening to this, that we don't talk to our students enough about this set of complex problems. We don't. And because I think it's partly because it's effort-filled to actually figure it out yourself, to be able to communicate it to somebody else. The other thing is that students are rapid consumers. They're like little vacuums, and if there's a lump on the floor and they don't want to take it, they don't take it, because there's not other places where it isn't there. And so as a result, we don't intentionally dumb things down, but we leave things out. We don't problematize hard enough so that students really have to struggle over the choices that we are facing, because they can handle it. I mean, they can really. I have 30 kids in a class on poverty and income security, and the reason that they're taking the class is because they want to know how'd they get to MIT. They want to know why them, who them. So I have them doing a genealogy. So for the first time, they're actually going to find out they have a great grandmother somewhere who was, a very important person. But most of the time, they're getting just rapid fire information, trying to pack it into a small space, and you always wonder what they remember.
So with that, we're going to take some questions from the audience.
Give them Legos.
That is not my opinion.
We'll figure it out.
So I want to know if Michelle or Amy need a 60-year-old or 61-year-old teaching assistant. So I
would be younger than me. I would be flattered.
So I blew up my career 5 months ago. I've 38 years in automotive energy, brought the Leaf to market, drove the first one off the line in Smyrna, Bloom boxes, did all this great stuff. And my company got bought, my battery company. So I was like, I had an opportunity out of the blue to be in mining. I mean, you can't make this up listening to this. So we're trying to start up boron and lithium in the U.S., in the ore body, in situ mining, so it's less bad. I won't say it's environmentally sound, but less bad. Processing plant's already built. We're waiting. We have an EPA permit, but we're waiting to clear the conditions. So I've got people trained that I trained myself. Half of them are women. So we took people from Walmart and Jiffy Lube and trained them to be chemical
Is this Arkansas?
operators. Nope, this is the Mojave Desert. This is
Okay.
Newberry Springs, California. So I'm just listening to this, and literally I feel like, I'm not as engaged as I would be because I feel like I have brain damage for the last 5 months of just all of the different constituencies that, the financial and the investors and the governments and the permits and all these kind of things. So I'm thinking maybe a better use of my time instead of going out and just continuing to do this fight is to come work for you guys and bring some experience, and maybe you can help me help tell the story. But
Why don't you, given your past, join the Women's Mining Coalition and help all the 535 kids on the Hill in Washington understand exactly what's at stake and what's going on?
Yeah, really.
No, I've never heard of it. I mean, because it's maddening because we're paying people $100,000 a year to do these jobs in a place where that's real money. Yeah. So they, and it's just, there's so much passion and it's so exciting, but every day I have to get up, put my armor on. I feel like going back, back in Wayne Assembly, which is a Ford plant that I think was on TV the other day, back in the 1990s. And so anyway, all four of you have inspired me, but the two of you in particular. Michelle, you're a reverence. It's between you and Evangelina. I might be able to go to work tomorrow.
Take the day off.
You made Naomi's day. You just made
Elsa, I actually think this is a perfect place to mention the consortium and what you do with companies and through the consortium, right?
Sure. Let's see here. So I was thinking about the consortium and Amy's point around students. So what Antje is referring to is the Climate and Sustainability Consortium that I co-direct, which is 18-member companies, but deliberately across the economy. So Apple, Cargill, Dow, PepsiCo. So kind of the idea is to try to have an illustration of what transition could look like and examples of those companies working together across economy with the MIT experts in the topics they care or don't have the right expertise in necessarily to try to showcase or understand what solutions would be that could be transformative across the economy. But through that, we've set up a program for juniors and seniors at MIT. It's called the Climate and Sustainability Scholars. And we have about 20 students. This is just the second cohort because the consortium's only a couple years old, where they're doing year-long research projects in different parts of sustainability with faculty on campus, but then they also come together to learn sustainability literacy together. But so it's deliberately cross-institute, so students from all the different schools on campus and having them come together to learn how to have conversations cross-discipline. And my co-instructor and I were noting to each other this year's cohort, so the second cohort, they're engineers, they're computer scientists, they're urban planners, and what they are very passionate about is almost every single one is the community engagement and climate justice aspect of it. So they're doing research in solid-state electrolyte battery development or looking at biodiversity by understanding the role of computer vision to count salmon, all those different very specific research foci. But what their passions are and interests are is in climate justice and in kind of the social elements of sustainability. And that's been really interesting. I no longer feel capable of teaching them sustainability literacy because where their passions are is not, where. So I think that the sort of the tricky, nuanced people part of this, I think is very loud, at least than what I hear from the undergraduate student perspective. So I don't know how that helps with it sort of, it maybe underscores the set of tensions you're feeling and exhaustion you're feeling about all the different conversations that you're having to moderate and try to affect change within, maybe is the source of that.
Well, maybe there's a company that wants to become a member.
Oh, I see. I'm happy to have a conversation.
Do we have any other questions?
I see Remy.
Okay, go.
Oh.
So just since we're wrapping up and we've all been talking about inspiration and where to go and being all excited. All right, so you guys have showed a lot of challenges. So talk to us about what we can all do from all these different stages in our careers and different interdisciplinaries. What can we do to address this really complicated issue?
Wow. Learn to communicate complexity.
Yeah. And actually create a narrative for yourself that you feel really confident in, and think in terms of the person you're going to deliver it and make modifications in it. I mean, that's all we do as teachers. I'd like to say we're Einsteins, every one of us, but we're really pretty much ordinary people. But what we do is we convince people of things that they initially don't probably think is correct. And so, half the time, if you're right half the time, that's half the time you're right.
Actually, so I'll add on to that. At the same time, what you need to do is caution yourself against all the things that they tell you that they believe to be correct. This is one of the biggest challenges, I think, is having the confidence to doubt what you hear, because everybody wants to believe that we know what we know, and we don't. And that is, we're not really good at that at all. Modern humans really are not good at that. And so question, there's nothing wrong with questioning, doubting, being a skeptic. Those are healthy, good, robust traits. You have to use them the right way.
Barchi, what do you think everyone here can do?
I agree with all my colleagues here. Just to have, on the one hand, an open mind and really embrace all the possibilities and know that there is a lot that we can achieve, but also some skepticism and about what you hear from others, because there are many different opinions and not necessarily everyone is completely correct. So yes, some skepticism is in place.
So there was one more question over there somewhere, I heard.
Wait.
Hi. I had a question kind of around the broader narrative. You've brought up the question of speed, and then Elsa, you were mentioning recycling. This kind of clean energy transition for me is really interesting because most of these minerals for the clean energy transition are located in the global south. And all of these economies are kind of also grappling with the question of development, feeding their own people. And so how do we kind of stop ourselves from falling into that trap of extractive economies once again? What are those kind of shifts in thinking that we need to think about the clean energy transition differently and in a more circular way and in a more involved way? Because I'm really scared that 60 years down the line we would have done this clean energy transition and then have this completely new wasteland that exists. So how do we break that cycle?
I actually worry about that a lot, and I'll share a thesis that I have. My thesis is that if we were really fair, unafraid to question, being properly skeptical, all of that, we did a full-blown, complete, well-done life cycle analysis, we would find our existing legacy fuels and systems actually are probably pretty good and probably are better than what we would get given the difficulty in planning, managing human behavior. And also just, think about this from an engineering sense. What we're trying to do is develop stuff that is very materials intense because of the properties. I mean, this came up a little bit yesterday from our good ERCOT board member in Texas, a little bit today from Becky Klein. Maybe Texas women just need to get out on the road a little more often, I don't know. But wind and solar are really interesting. They're really attractive. But there's nothing renewable about them. I mean, they do not exist without a lot of non-renewable stuff. And we never talk about the entire system associated with those technologies. God, what we've been going through in ERCOT to try to use this stuff, you have no idea the billions of dollars we've been spending to try to balance it, integrate it, manage frequency, have the right backup, energy storage, because it's not energy storage, and so on and on and on. That creates the materials intensity, which is actually creating the problem. And so I think that to that fork in the road, what is it that we really are trying to do here? There's nothing wrong with looking at what we have now and the footprint that's associated with it and doing it better without having to create new hazards, as you're pointing out, and places where dealing with those hazards is not actually going to be very easily done. And that is a taboo subject. You know, if I try to bring that up wherever, in an SF meeting, something like that, man, this is like, you cannot talk about this. So that's dangerous to not be able to put this on the table and have people really, really look at stuff. I have to tell you that listening to Peggy yesterday, I do not apologize for natural gas. Man, this is a fantastic resource. We have to use it wisely. It's so powerful. You wouldn't have wind and solar without natural gas. You need the materials and you need the backup. And I can tell you that from Texas. There is no way to do these technologies without that. But until we're ready, to be honest, in the conversations, we're not going to talk about this the right way. It's not going to get on the table the right way. So
I would say that don't oversell.
yeah,
That's one of the, I think that's
basically what's been
really
going on.
just a single line of it is we have to be very careful, even about the notions of just transition. All these words that we use, we're using words that have had purposes in other contexts. And I think people become infatuated with it just because it sounds new. But we have to be really careful, because if we oversell, then it'll come back on us in a very negative way, and it can set us back a long time. And I think your idea about, what is the system today, and I mean, from the standpoint of where the world works, the system does function right now. And but
it could function better.
Yeah, exactly.
And Barchi, you had your head up.
Yeah, I just wanted to share that I do share the same concerns with regards to, yes, we wanted to transition to renewable energy, like Michelle said, but all the materials that are needed are not renewable, and we really need to keep that in mind. And I think it's very important to adopt more circular economy concepts into the clean energy sector, and look at ways in which we can recycle. I mean, if looking at the solar energy sector, then those solar panels, they have a lifespan of, say, 20, 25 years. We're going to have a lot of those panels that are no longer in use in a number of years. Instead of them reaching landfills, it's really important to find a way to reuse all those materials. And in order to be able to do this, just one last point, it's important to start thinking about this early on when designing those panels, to make sure that there is an easy way to extract those materials back for reuse when they reach their end of life. So I'm definitely in favor of that.
Also, in 30 seconds, can you put an even more positive spin on that?
Shall we go have a reception? Is that a positive spin on that?
If you're not going to rise to the challenge, are you going to rise to the? Are you going to?
I have to go pick up some children, so I'm feeling a little time pressure.
Already over time. You can
Elevator on the just elevator on my carbon sales pitch. I can build a circular economy, closed loop circular economy around this stuff, and I can give you the properties that you can get from a lot of metals, including for solar, for advanced solar. This is the kind of stuff that right side fork of the road, the slower path, will help us to get. I just want to have the conversation. I can't even have the conversation. Help me get the conversation, and we'll be able to.
at the reception. And with this, I would like to thank our panelists. And I think this
Really, yeah.
And also, Michael Lewis pegged it exactly right.
Have you read Thomas Kuhn's